then on Monday, we're going to practice everything we learned in this lesson. And then on Tuesday is going to be your first quiz in trigonometry over the unit circle. Okay, so today we're mostly going to be talking about like the building blocks of the unit circle. You might fill a little bit more of it out. I know we've got our angles on there already. And then tomorrow will be more about filling out the unit circle and how to use the unit circle, which is what that quiz is going to be over next week that we're going to practice for. Okay, so things we need to know in order to get our unit circle. First of all, we need to talk about this picture right here. Okay, so we talked about in section 5.1 that angles in standard position are going to start on the positive side of the x-axis, and then they're going to rotate either clockwise or counterclockwise. As soon as we take a triangle and put it in our quadrants, those side lengths now could be considered positive or negative, and they're going to relate to those angles we talked about rotating. All right, so if I'm in quadrant 1, of course, all my sides are positive. But if I'm in quadrant 2, the side along my x-axis would be negative. If I'm in quadrant 3, my x and my y are negative. And if I'm in quadrant 4, my y is negative. And we can see that when we kind of draw the picture. So we'll be drawing a lot of triangles and quadrants for this section. All right, if we have a triangle, and this could really be in any quadrant, but the picture that we use to get all these things is in quadrant 1. We pick some arbitrary point in any quadrant. That point is x, y. From that point, we drop what we call an altitude down to the x-axis, so it makes a 90 degree with the x-axis. And then we connect our point to the origin, and that's always going to create a right triangle. When you draw right triangles, and this is so important, guys, the right angle must always be on the x-axis, and your theta must always be next to the origin. Okay, that is the only correct way to draw a right triangle in our quadrants. Angle is always on the right axis, or on the x-axis, the right angle, and our theta is near the origin. From there, once I have the triangle picture, x is the horizontal, so we label that side, could be positive or negative. Y is the vertical, again, could be positive or negative. And then we label the hypotenuse as r, because eventually it's going to represent the radius of a circle, so that's why they're using an r for that. From this picture, you can find all 6 trig ratios like we did in section 5.2. Sine of this angle is opposite over hypotenuse, y over r. Cosine is adjacent over hypotenuse, x over r, so on and so forth. So all of these that you see over here, those are just our opposite adjacent hypotenuse ratios we talked about already, but just in terms of this triangle instead. When it says something can't equal 0, that's because those guys, for each of those little trig functions, are in the denominator. So we know we're not allowed to divide by 0. It's just going to make that trig function undefined. Sine and cosine will never be undefined, but our other trig functions can. The reason sine and cosine will never be undefined is because your r value, it's like a radius of a circle, will always be positive. So x and y could be negative, depending on what quadrant you're in, but r is always positive. All right, so let's do some examples. Suppose theta is an angle whose terminal side contains the point 2, -5. Find the exact values of the 6 trigonometric functions. All right, so we're going to draw a picture. Maybe. Here we go. Here's my axes. What quadrant is 2, -5 in? It is in quadrant 4. Okay, so I'm going to plot it roughly 2, -5. Okay, and that is where an angle has stopped rotating. It's the terminal side. Okay, so it's like a ray, but there's an end point to it. From the point, and this is the important part about how we draw these triangles, we're going to connect that point to the x-axis, always the x-axis. So in this case, I have to draw a line up. That's my right angle. And then my theta, again, very important, is always inside the triangle where the origin is, right there. Okay. Once I have that, I can label the legs of the triangle. Your horizontal leg is whatever your x coordinate is. Your vertical leg is whatever your y coordinate is. So 2 and -5. How do I find a hypotenuse in a right triangle? Pythagorean theorem. Okay, and again, it will always be positive, this hypotenuse. So 2 squared and 5 squared, we can do that in our head. What is that? It is 29. Yep, okay, and then take the square root of it. Add 29. Once you have this picture, you can then just use your SOHCAHTOA ratios to find all 6 trig functions. So let's say I want to find sine of theta. Okay, so that would be opposite over hypotenuse, -5 over rad 29, which hopefully you're being able to do this a little quicker. If I multiply by that radical over itself, I'm going to end up with -5 rad 29 over 29. And then if I want to flip it to get cosecant, remember you can flip either one. If I were doing it, I would flip the first one, so I don't end up with a radical in the denominator and I don't have to rationalize. Save myself a little bit of time. Cosine is adjacent over hypotenuse, so 2 over rad 29, which would be 2 rad 29 over 29. And secant, again, I would probably flip that first one, rad 29 over 2. And then last but not least, tangent, opposite over adjacent. Opposite is -5, adjacent is 2. That one's easy. And to get cotangent, the reciprocal, -2/5. All right, so the new part here is, if we have a point, how do we draw that triangle? And then there could also be some negatives in there that we're going to consider once our triangles aren't floating around in space anymore. Any questions on this first slide? First problem. Okay. Another little helpful thing that we have in trigonometry is this wonderful little chart here. Now, if I were going to write anything down, and like this is literally something you guys could do in like the top corner of every test when you get it this semester, is make a little, I don't know, axes, I guess, and just put A, S, T, C. Okay, so this represents our 4 quadrants. A is quadrant 1, S is quadrant 2, T is quadrant 3, and C is quadrant 4. Those axes that I drew can also represent a big plus sign, because that's what this chart tells you. It tells you which functions are positive where. So the A in quadrant 1 tells me all 6 of my trig functions are positive in quadrant 1. The S tells me that sine, and of course it's reciprocal if I flip it, are positive in quadrant 2. Everything else in quadrant 2 is negative, except for sine and cosecant. In quadrant 3, everything is negative except for tangent, that's what the T is, or cotangent. And in quadrant 4, everything is negative except cosecant and secant. So how can we use that for problems like this? It says if sine of theta is greater than 0, which is a real fancy way of saying sine is positive, and cosine of theta is less than 0, so cosine is negative, in which quadrant does that angle lie? Either 1, 2, 3, or 4. All right, if sine is positive, that narrows it down. There's only 2 places in my quadrants where sine could be positive. Where are those 2 places? Well, could sine be positive in quadrant 1? I mean, everything's positive in quadrant 1, right? Okay, and could sine be positive in quadrant 2? That's what the S means. Sine is not positive in 3 or 4. So that first piece of information tells me, all right, it's got to be in quadrant 1 or 2. But now I know cosine's a negative. So that narrows it down more. Is it in 1 or 2? How do you know it's in 2? Because if it was in 1, cosine would be positive. Everything's positive in quadrant 1. So because something's negative, it can't be in quadrant 1. Okay? All right. So given that tangent of theta is -4/5 and cosine of theta is greater than 0, find the exact values of sine and secant. So these first 2 pieces of information are allowing us to draw the triangle. The triangle is going to give us the 2 answers we need later. So right now we're just focusing on getting this picture. I would first start with, because it doesn't give me a point like the last problem, and it doesn't tell me a quadrant, that's your first task. What quadrant is this triangle going to be in? Okay, so tangent we know is a negative number, and cosine we know is a positive number. All right, so we've got to figure out of those 4 quadrants, where is tangent negative, but cosine is positive? In quadrant 4, good. Okay, because we know cosine is positive in either 1 or 4, but something's negative, so it can't be in quadrant 1. So how does that help me? Well, I can pick an arbitrary point in quadrant 4, doesn't matter where that point is, and draw the triangle in a similar way to what we did with the last one. Connect that point to the x-axis, there's my right angle. Connect it to the origin, there's my theta. I know what the tangent is here. I know the tangent is -4/5, and tangent is opposite and adjacent. So I'm going to label my sides. Now I'm not going to put a negative in there yet. 4 is opposite, adjacent is 5. Remember, when a fraction is negative, the numerator could be negative or the denominator could be negative. We don't know which one. So you have to figure out, based on this picture, which number makes sense to be negative, the 4 or the 5. The 4 makes sense to be negative here. Yeah. Okay. And then 4 squared and 5 squared, if I do my quick little Pythagorean theorem, that's 16 and 25 gives me 41. Rad 41. Once you have this picture, you can find all 6 trig functions. It's only asking for 2 here, though. It's asking for sine and secant. What's the sine of theta here? Perfect. And then if I rationalize, -4 rad 41 over 41. And secant. Secant's the reciprocal of which function? Cosine. Cosine is adjacent over hypotenuse. So if I want secant, hypotenuse, rad 41 over adjacent. All students take calculus is also a way that you can check your answers. If I'm in quadrant 4, cosine and its reciprocal should be the only 2 things that are positive. Well, secant is the reciprocal of cosine and it's positive, and all my other answers, which is sine, is negative. So it's a way to check your pluses and minuses at the end. Because if you draw the triangle in the wrong quadrant, the only thing that's going to change is your plus and minus sign. That's it. So it's like it's not, throwing the whole problem off. But it, in Math Excel, it's obviously going to make a difference. So we want to be careful about that. All right. Any questions there? Cool. Okay. So we are going to use what you saw on the first page. Go back a little bit here. The y over r, the x over r, the y over x, to get some special trig values that we're going to need for our unit circle. These are the last ones we're going to need to actually fill out the unit circle. So we have special angles. We call them quadrant angles, 0, 90, 180, 270, and 360. They are special because when I have a point on one of those axes, I can't draw a right triangle when I connect it to the x-axis and to the origin. So we need these alternate definitions, x over r, y over x, to find the value of those trig functions. And we're finding them once now, but these will be on your unit circle eventually. So it'll be something you can quickly find and not have to like recreate the wheel over and over again. All right, so we're gonna do the first one together, maybe the second one too, we'll see. 0 degrees. Okay, so if I'm at 0 degrees, I'm over there somewhere, right? It starts rotating there, it stops rotating there. That's where my point on my terminal side is located. So it's a point on the positive side of the x-axis. Well, what do I know about the coordinates of that point? If it's on the x-axis, what do you know about the y-coordinate? It's 0. And the x, we're just going to call it x. We don't know what it is. It could be 2, 0, 5, 0, whatever. Okay, so that's my point. That's my x and y. We also need an r. Now, I said r is like a radius of a circle, okay? Now, imagine my circle starts at the origin, and this point is on the outside of the circle. This is r. R is your distance to the origin. If my point is x, 0, how far is that from the origin? It is x units away. So in this picture, my radius would be x. All right, that is all we need to find all 6 trig functions. Here's how you do it. Sine is y over r. In this case, what's my y-coordinate? And what's my radius? What's 0 divided by anything? 0. And actually, I probably shouldn't have put a theta there. Let's put a 0 degrees there. And 0 and 360, remember they're coterminal angles, so they're going to look exactly the same. So whether I put a 0 or a 360, the sine of 0, the sine of 360 is 0. All right, so then if I wanted the cosecant of 0, all I have to do is flip that. So instead of 0 over x, it's x divided by 0. Am I allowed to divide by 0? I am not. So the cosecant of 0 is undefined. If you want cosine, that's x over r. What's my x coordinate? And my point, what's my x coordinate? X. What's my radius? X. What's x divided by x? 1. And what would the secant of 0 be if I flip that? It's also still x over x, so 1. The last two, tangent is y over x. Y is 0 in my picture. X is x. 0 divided by anything is 0. And finally, cotangent. If I flip it, it's x over 0 now, which is undefined. Okay, so those are the 6 trigonometric values for 0 or 360 degrees, because those are going to both end in the same spot on my axes. Okay, so now what you're going to do, and I'll get you set up with the next one, you guys are going to do 90, 180, and 270 the same way. So for 90, here's what this would look like. I'm going to have a point up there somewhere. Can you tell me the coordinates of that point? As much as you can tell me about them? 0 and y. And then what would my radius be here? Distance to the origin. Y. Okay. For 180 and 270, because you're going left and down, something's going to be negative. The radius won't be negative, but part of your point is going to be negative. So be careful with those. All right. So take, actually, let's do this. I'm going to give you guys 10 minutes now. I'll do cell phone lotto and stuff. We're going to put the 90, 180, and the 270 on the board to start class tomorrow to make sure you have them. So you guys can take the last 10 minutes, try 1 or 2 of them on your own, and then we'll come together and check them, and then tomorrow we'll get the rest of that unit circle filled out and grab up the lesson. Okay?